Okay, so today I am going to discuss the GATE 2025 2 marks question solutions. Okay, so let's start. Okay, so I am not going to read every question. You all have the answer keys and responses. So I am not going to read every question. You know what is the question is. I am just discussing the solutions. Okay, this is the 37th question. Okay, so this is the one loop. This is the planar loop in XY plane. Okay, so if you notice the the current direction is anti-clockwise. So the magnetic moment for this loop will be in upward direction, in z direction. That is equal to I into area, and area is simply d squared, so it is I d squared, right? Now for the second loop, the loop is tilted along 30 degree. Okay, and if you use the thumb rule to get the magnetic moment will always be perpendicular to it, so it will be in this direction. Okay, just use the thumb rule. You can rotate the screw and you will get that it will like curl like this. Okay, so it will like perpendicular to this. Okay, so this is the direction of the second magnetic moment due to the upper loop which is tilted at 30 degree. It is again id square, right? So you have two magnetic moment, each of value m is equal to id square, and the angle between them is what? Okay, so this is 30 degree, so this is 30 degree, and the total angle is 180 degree, so this is 60 degree, so this is 120 degree, right? So the angle between the two magnetic moments is 120 degree. Okay, so the net magnetic moment, the value of net magnetic moment is m plus m plus 2m cos 120, right? Cos 120, and cos 120 is what? Cos 120 is minus half. So the simply the final result will be just m, that is I d square, right? The two vector, the vector addition of two vectors, that's the simple thing. The second problem is like this is the configuration, the values of m and k1 k2 are given. So basically you have to write the Lagrangian, or you can directly write the t and v and do the small oscillation analysis. Okay, so the Lagrangian is m by 2, that is 1 by 2, m is equal to 1, x1 dot square plus x2 dot square, right? I am assuming this has displacement x1, this has displacement x2, right? So this is kinetic energy term, and the potential energy term is what? Potential energy term will be the first spring k1 by 2 x1 square plus the second spring which has displacement x2 minus x1 whole square plus the third spring that is again k1 and its displacement is x2, so x2 square. So if you now you can easily accumulate the term with x1 square. X1 square has coefficient k1 plus k2 by 2, x2 square has coefficient k1 plus k2 by 2, and x1 x2 has coefficient just minus k, sorry, minus k2, right? So this is the configuration. Now if you can if you now able to form the matrix Vij minus omega square Tij, right? You can form this matrix, so it will like simply like 5 minus omega square minus 3, 5, sorry, is again minus 3, and 5 minus omega square, right? This is will the matrix, and the determinant of this will be 0. So omega square minus 5 is equal to plus minus 3, omega square is equal to 2 comma 8, so omega is root 2 root 8, right? So this will be the answer. The third question, may you be little afraid in the exam hall because of the term this quadrupole contribution. Okay, but actually this thing is not very complicated. So if you write the form of the potential has the form q by 4 by epsilon naught sum over r prime to the power n into r to the power n plus 1 into pn cos theta, right? So if you get put n is equal to 0, you will get the monopole. For n is equal to 1, you will get the dipole. N is equal to 2, you will get the quadrupole. Right? So put just n is equal to 2, right? So q by 4 by epsilon naught r prime square r cube into p2 cos theta, that is 3 cos squared theta minus 1 by 2. Right? Now just look at the configuration of the charge distribution. Okay, so these things, this r prime theta, all are in spherical polar coordinates, right? Now in this given configuration, see, this is the ring, this is the ring, right? This is the ring, and it is entirely in xy plane. So what should be the value of theta? Theta in spherical polar coordinate, right? So theta will vary like 0 to pi, from this to this, right? Theta will vary from 0 to pi. So theta is equal to pi by 2 will give you the xy plane. Okay, so just simply put theta is equal to pi by 2. The first thing is like this. So it will be q by 4 pi epsilon naught r prime square by r cube into minus half, right? Now another next thing. The next thing is that your entire charge distribution, is that r prime is equal to r. There is no other thing. So you can write is a theta r prime minus r. Sorry, theta, not theta, delta r prime minus r. So your entire charge distribution is that r prime is equal to r. Otherwise, there is no charge distribution. Simply replace this r prime by capital R. So minus q by 8 pi epsilon naught, and your r is already d, so it is dq into r square. Now what is your q? Q is not a constant here, right? Q is the integration of this total thing. So what is the integration of this total thing? It is simply r 2 pi r into lambda, right? Lambda into 2 pi r, nothing. So if you substitute this, it will be lambda into r cube. 2 pi will make it 2 pi, and 8 pi make it 4. So 4 epsilon d cube. Okay. So this will be your answer. The next thing is, okay, so you have this configuration, and they are basically asking you, the thing they are asking, that whatever be the d2, the final result, in the final result d2 will be suppressed. That means if your d1 is equal to 1, then your output y should be is equal to d1. And if d1 is equal to 0, again your output y is equal to d1. So output y will not see what d2 is. Output y will only see what d1 is. So you have to build your gate, your configuration with d1 and d2 in such a way that the output will only see what is d1. Output will not see what d2 is. It doesn't matter. Okay. So I am not showing the every options here, because the first option is correct. Because let's see the first option. What is y? Y is simply d1 d2 bar, right? Y is d1 d2 bar. Now let's say d1 is equal to 1. That means d2 is equal to 0. So it will 1 into 0 bar, that is 1. So y is equal to 1 is equal to d1. Now suppose d1 is equal to 0, that means d2 is equal to 1. So 0 into 1 bar, that is 0 into 0 is equal to 0. It is again d1. So in this configuration, the output is only seeing what d1 is. It is not seeing what d2 is. So this will be the right option. You can check other options also from your answer key. The other options will not give this kind of configuration, that y is equal to d1. Both is satisfied. Okay. The next option, next question. So next question, you have some n plus particles in plus e state and in minus particle in minus e state, and total number of particles is n, and the total energy is e, right? Total energy is e. So e is simply n plus minus in minus into e, and n is equal to n plus plus n minus. So you can calculate what n plus and n minus is. So n plus is n plus e, capital E by small epsilon by 2, and n minus is equal to capital N minus e, capital E by small epsilon divided by 2. Right. So now they are telling you what is the inverse temperature. So you can immediately recall from your previous knowledge that 1 by T is nothing but del S del E, right? Other things are fixed, v and so del S daily. So what is S? S is equal to k log omega. And what is omega? Omega is simply n factorial divided by, I mean, you can write it as ncn plus or ncn minus. Doesn't matter. Both these are same actually. So it is n factorial divided by n plus factorial divided by n minus factorial. Okay. Now you can bring this approximation technique. They are already mentioned in the question that you can use this approximation. So it is k log n log n minus n minus n plus log n plus minus n minus log n minus plus n minus, right? Now n is equal to n plus n minus. So this term together will cancel, right? Now this is your s. Now if you do the del s del e, this term will give you nothing because this is n log n is a constant. So this term will vanish when you do del s del e. So your only surviving term is, sorry, there is no log here. Okay. So your only surviving term is del n plus del e into log n plus minus del n minus del e log n minus n plus, and if you do del log n plus, okay, so let me write it properly. Del log n plus del e minus n minus into del log n minus del e, right? So if you calculate these two term will exactly cancel each other. One will give you plus E by epsilon, and another will give you minus E by epsilon. So your only contributions is coming from these two terms. Okay. So now let what n plus is. N plus is n plus E by epsilon by 2. So if you do del n plus by del E, you get 1 by 2 epsilon. Okay. So minus k by 2 epsilon log n plus, and if you do del n minus del e, you similarly get minus e by 2 epsilon, because there is a in, I am writing in minus as n minus e by epsilon by 2. So if you differentiate with respect to e, you will get an extra minus sign. So it will be k by 2 epsilon log n minus, right? So your final result will be k by 2 epsilon log n minus divided by n plus. So that is equal to n minus e by epsilon by n plus e by epsilon. So calculation is bit lengthy, but the process is straightforward. Okay. This problem is actually easy, because see, p and x, you have don't care about what is the coefficients of this. It is simply write some coefficient into a minus a dagger into some coefficient into a plus a dagger, right? So you have terms a square plus you have term a dagger square plus you have term a dagger a. Okay, so let me write it carefully. Plus a di no, this is minus a dagger a plus a dagger, right? Kind of this. There is some coefficients. Don't care about this. So now, if you have to get a finite value from this, so your aim should be right n minus 2, right? Because a square will lower this by 2, right? If you operate a on n, it will give you n minus 1. Then again it will give you n minus 2. So you have to, if you have to get some finite result, you have to aim is equal to n minus 2. Similarly, if you want to get some finite result from this configuration, your aim should be is equal to n plus 2. And for a dagger or a dagger a kind of term, your aim is equal to n, because a will lower this end and a dagger will up the, I mean, get it pushed to the upper end. Okay. So these three configurations are possible to get finite results. So only option B is satisfying all of these three. Okay. This is the next question. Okay, so you have two level quantum system has energy E1 and E2. The perturbing Hamiltonian is of this form, where sigma is the Pauli matrices, and the magnitudes of first and second order corrections to E1 due to H prime. So you have some Hamiltonian H that is equal to E1 0 0 E2 kind of form, and your perturbing Hamiltonian has some form lambda delta into 0 1 1 0, right? So E1 has energy eigenvectors say 1 0, and E2 has say energy eigenvectors 0 1, right? Now you can clearly see what is, you can clearly calculate that what is, you have to calculate for E1. So E1 has this eigenvector 1 0. So E1 H prime, that that is h prime is lambda delta is 0 1 1 0 into 1 0. This is the first order correction, right? This is the first order correction, and this will it will give you 0. Now the second order correction, there is only two state, right? So this is 0 1 h prime 1 0. I mean, these are matrix. Okay, these are matrix mod square divided by e1 minus e2. This is the configuration of the get to state. Now what is this element? This element is lambda square delta square into 0 1 h prime is 0 1 1 0 and 1 0 and mod square. So if you calculate this element will give you 1, right? So it will be lambda square delta square divided by e1 minus e2. Okay, so this is the second order correction. Okay, so this option will be correct. The next one, so the electron with mass m and charge q initially at spin up state at t is equal to 0. A constant magnetic field is in this direction, j cap direction, and the Hamiltonian is given by this. Okay, so omega is this. Don't care about what is this, and sigma oy is this. The second Pauli matrix. So minimum type after which the electron will be in spin down state along the x-axis. So they already again give that what is the spin down state along x-axis. So they reduce your burden so much. Okay, so now this Hamiltonian has two eigenvalues, that is h cut omega and minus h cut omega and h cut omega. Okay, so this initial state is 1 0. You have to decompose it in Hamiltonian of sigma y, because the Hamiltonian is form of sigma y, so you have to decouple it in form of the eigenvectors of sigma y. Okay, so what are the eigenvectors of sigma? Let me first decompose it. So you can write it as 1 I plus half into 1 minus I, right? So if you add this to I minus I, will give you 0. 1 plus 1 will be 2, and 2 plus, I mean 2 and 2 will cancel, and they will give you 1 0. So these are exactly the eigenvectors of sigma y. So the sigma y for the positive eigenvalue, the plus 1 eigenvalue, the eigenvector is this 1 I, and for the minus 1 eigenvalue, the eigenvector is 1 by root 2 1 minus I. Just like the sigma x, this minus 1 will be replaced by minus I, and the plus 1 will be replaced by plus I. Nothing else. Okay. So this is the decoupled form. So now straightforward do the time evolution, right? This is psi t is equal to 0. So what is psi t is equal to t? Do the time evolution. So 1 by t, 1 I, and you have e to the power I h cut omega divided by omega. So it will be e to the power I omega t. Okay, plus 1 by 2 1 minus I into e to the power minus I omega t, right? And now this is psi t is equal to t, and your final state will be this, should be this. So you have to take the, I mean, if this is say psi x, then your probability of psi x at psi t is equal to t at the minimum time when it will flip, this probability should be is equal to 1, right? If this state will evolve to this state, then when it evolves to this state, the probability of getting this sigma x is equal to 1, right? So probability is sigma t t square, right? So what is sigma x? Sigma x is this, and now if you take the inner product, so it will be 1 by 2 root 2 into 1 minus I into e to the power I omega t plus 1 plus I into e to the power minus I omega t, right? And you have to do mod square of this, mod square of this, right? So let me write it again carefully. So see, here is 1 into e to the power I omega t. Here is 1 into e to the power minus I omega t. So this two term will combine to 2 cos omega t, right? And here is I to the power minus I omega t and minus I to the power I omega t. So if you take minus I common, e to the power I omega t minus e to the power minus I omega t, this kind of term is formed. and this is nothing but 2i sin omega t. So I and minus I will give you 1. So this total term will give you 2 sin omega t. Right? So and 2 will cancel. So your final result will be cos omega t plus sin omega t by root 2 whole square, and this should be is equal to 1. Now this upper numerator will be 1 plus sine 2 omega t, because cos square plus sine square is equal to 1 and 2 sine cos is equal to sine 2. So it will be sine 2 omega t is equal to 2. So sine 2 omega t is equal to 1. So it is simply pi by 2 for the minimum time. It can take value 3 pi by 2, 5 pi by 2, this kind of values also. But you have to look at the minimum possibility. So this is the minimum possible value of sine theta is equal to 1, theta is equal to pi by 2. So t is equal to pi by 4 omega. Okay. So this will be the correct option. The next problem you can solve it in two ways. The first thing is you can first do what is the value of s1 plus s2. S1 plus s2 can take two values 0 and 1, and s3 can take two values, that is, sorry, s3 has only one value, that is half. Okay, so you have this one value with one value, this one value with another one value. So if you call s is equal to s1 plus s2, then your Hamiltonian is a h cut square s dot s3, right? And what is s dot s3? So a h cut square into h cut square by 2 into s plus s3 whole square minus s square minus s3 square, right? Now for let's say s is equal to 1 you are calculating. So for s is equal to 1, what is the possible values of s plus s3? So s is equal to 1, your possible values of s plus s3 is 1 minus half is equal to half and 1 plus half is equal to 3 by 2. These two values are possible. Okay. So a by 2 into your, let's say we are calculating with 3 by 2, that is 50, it means 3 by 2 into 3 by 2 plus 1 is equal to 15 by 4 minus s square. So it is 1 into 1 plus 1 divided is equal to 2 minus s3 square, that is half into half plus half, that is 3 by 4. So you have this one value. So 15 minus 3 is equal to 12, 12 by 4 is equal to 3, 3 minus 2 is equal to 1. So one value is a by 2. Now let's say you are calculating with the, this is s plus s3 is equal to 3 by 2 for this. Now let's calculate with s plus s3 is equal to half. Okay, it is 1 a by 2 into 3 by 4 minus 2 minus 3 by 4. Right? 3 by 4 will cancel, it will give you minus a. Okay, so from this to calculation you can already fixed it out that what is the right option, this will be the right option. Okay. Now this configuration, you have to tell which one is Fermi transition and which one is Gamow-Taylor transition. Okay. So look this configuration. This is in this case, what is your L value? The change in L, that is equal to 0, because 0 to 0 is 0, and your minus 1 to the power j, that is equal to here plus 1, right? Minus 1 to the power j is equal to plus 1, and j is L plus L j beta, say j beta, because this is beta decay. So and j beta is simply L beta plus S beta, right? And this is L beta. Okay, so let me denote the beta. Okay, so now j beta will also, this is minus 1. Okay. So minus 1 to the power 0 is already plus 1. So your s beta is 0, because this is j beta, this is 0. If you add it with 0, you will get 0, will get 0. If you add it 1, it will give you 1. Then minus 1 to the power 1 will be minus 1, not plus 1. But you have to get, parity is conserved. So you should have j beta which is 0 or 2 or 4. So in this case only s beta is 0 is possible. So this is definitely, this configuration is definitely a Fermi transition, because s beta is 0. Now look this configuration. For this configuration your L beta is equal to 1, but your parity is conserved. Your parity is conserved, that is minus 1 to the power j beta is equal to plus 1, because plus to plus. So your j beta should have 0 to this kind of values. Okay, now if you choose S beta is equal to 0, then what is your J beta? J beta is L beta plus S beta. So L beta is already 1, so 1 plus S beta. Now if you choose S beta is equal to 0, your J beta will be what? J beta will be 1. Right, 1 plus 0 is equal to 1. The only possible value of J beta is equal to 1. Then minus 1 to the power 1 will be minus 1, not plus 1. So S beta can't be 0 for this case. Now if you choose S beta is equal to plus 1, S beta is equal to 1, what is the value of J beta? J beta is equal to 1 minus 1 0 and 1 plus 1 2. So these are the two possible values of J beta. And your minus 1 to the power 0 is equal to plus 1 and minus 1 to the power 2 is also plus 1. So S beta is equal to 1 is the possible for this configuration. So this is a Gamma-Taylor transition. Okay. So for this configuration, S beta is 0 is the possibility, and for this configuration, S beta is equal to 1 is the possibility. So this is Fermi-Taylor. First is the Fermi transition, and this is the Gamma-Taylor transition. Okay. Okay, now this problem. Point charge Q is placed above D in infinite grounded conducting plane. Okay, so this is the usual image problem which you do. So the upper region phi 1 is this one, the potential, and the for lower region the for the lower image charge the potential is this two, and the total potential is phi 1 plus phi 2. So which of the options are correct? Okay. So this is Q, this is minus Q, and distance between them is 2D. Okay. So what is the force? Force is 1 by 4 pi epsilon naught into Qs square by 4D square. So 2D whole square is equal to 4D square. So it is 16 pi epsilon naught D square. So option A is surely correct. Now for this configuration, for this configuration, you can write q square by 4 pi epsilon naught. You will write that the distance between them is 2D, so it will be 2D. You can imagine this, you can get this wrong, but this is not correct for this energy configuration. The energy has something subtle in this case, because this is the conductor. Okay, so the electric field will not go into this region. Electric field is only present in this region. Okay, so in this region there is no electric field, so the energy configuration will multiply by a factor half, so it should be 16, but it is given as 8, so it is wrong actually. Okay. Now the induced surface charge density on the plate is proportional to this. No, induced surface charge density is proportional to r square plus d square to the power 3 by 2. Okay. So where r square is x square plus y square. Okay. So it is not proportional to x square plus y square plus d to the power half. It should be proportional to the power 3 by 2, not half. Okay. So it is also wrong. The electrostatic potential phi 1 satisfies the Poisson's equation z greater than 0. Okay. Yeah, it is true. It is true because see q and minus q, the total configuration will satisfy the Laplace equation because the charge free region. Okay, so the total potential phi is equal to phi 1 plus phi 2 satisfies Laplace equation. But individually phi 1 only satisfies Poisson equation, because if you look at z greater than 0, your del square phi 1 is equal to some q by epsilon naught. I mean rho by epsilon naught actually, but there is this, the only charge here q is present here, so it is satisfying the Poisson's equation. Okay, so the total configuration, total phi is satisfying Laplace equation, but this phi 1 is satisfying Poisson equation. So this is Poisson, and this is Laplace. This is Laplace. The phi is satisfying Laplace. Okay. So this is also correct. Now problem, you you should have a little knowledge about how to do tensor transformations and the Lorentz group or Lorentz boost kind of thing. Okay, so I am not going in very detail of the things. I actually know a little bit of special and general relativity, so I am able to solve this problem. But this is actually a, you have to know some extra things like tensor transformations and Lorentz group things. Okay, so suppose you have a like this A matrix, and you want to do a frame transformation under this Lorentz boost. Okay, so if your Lorentz boost is some, say, lambda. Okay, so your A mu nu, say, in some frame A mu nu will be, so lambda mu alpha into lambda nu beta into A alpha beta. This is the tensor transformation rule. Okay, so mu, you have to get mu nu. So this is repeated index mu. sorry, this is repeated in this, alpha is repeated here and beta is repeated here, so alpha alpha will cancel and beta beta will cancel. Well, not cancelled actually, I mean you can assume, you can think like this to get this kind of configuration. So mu mu will cancel, so you will get mu mu. Okay, so alpha is the repeated index, beta is the repeated index. Okay, here, and this is the Lorentz boost matrix. Okay, so if you try to write this, these are in components. Okay, these are in components, but if you try to write this in matrix form, so if you can write this lambda transpose a lambda. Okay, so this is the matrix form and this is the component form. Okay, so you can do both these things. Okay, so you can write a prime tt, if you mu nu is tt, then lambda t alpha into lambda t beta a alpha beta. Okay, now you want tt, because now you want tt and txx, right? So I am fixing mu is equal to t and nu is equal to t. This alpha beta repeated in this, so alpha beta can take value t, can take value x. Okay, so this is att, this is axx, right? So lambda, this will be lambda tt, lambda tt att plus lambda tx, lambda tx axx. This is the component, I mean component wise you can look like this, but I will prefer the matrix form. Okay, the Lorentz matrix form. So the what is the Lorentz matrix? Lorentz matrix is minus gamma, gamma minus gamma v, minus gamma v, gamma. Okay, this is the Lorentz matrix, the lambda matrix. Okay, so the lambda transpose a lambda, you have to do this. Okay, so lambda transpose is simply gamma minus gamma nu minus gamma v, sorry, nu, not nu, gamma v, gamma. What is your A matrix? A matrix is P00Q. Okay, and what is your lambda matrix? Lambda matrix is gamma minus gamma v minus gamma v, gamma. Okay, we have to do this matrix operation. Okay, so gamma minus gamma v minus gamma v, gamma. Your p0 into this is equal to gamma p. This is gamma vp. This is gamma vq. And this is gamma q. Okay. Now again do the matrix calculation. So it is gamma square p plus gamma square vq. Okay, you are only interested in a prime tt and a prime xx, right? You are not interested in what is a prime tx and a prime xt, right? So don't calculate these two terms. Okay, don't calculate these two terms. I mean they are some value, but don't calculate this, don't waste your time. Okay, we are only interested in the diagonal entries. Okay, so this is one thing. And you are taking now this row with this column, this will give you this diagonal element. Okay, so it is gamma square v square p plus gamma square q, right? So this is a prime tt, this is a prime xx. So yeah, this is a prime tt and this is a prime xx. This will be the two options, I guess. Yeah. Now this question. So you have L is equal to given like m by 2 v square, that is x dot square plus y dot square plus z dot square plus qb into x into y dot, vy is y dot, minus y into x dot. Okay, so this is your L. Now the first option is saying what is dx dt, that is x dot, right? X dot is what? X dot is simply, no, sorry, it is dx dt is px, right? No, sorry, x dot. So let's calculate first the what is px. Px is del L del x, del L del x dot, right? So what is del L del x dot? It is m x dot minus q b y, right? So x dot is equal to px plus q b y by m, right? This is your x dot. This is your x dot. So this option is definitely not correct, right? So it should be plus. Now, what is your y dot? Y dot is simply del L, sorry, del L del uh, sorry, I am making some mistake. Py is del L del Y dot. Sorry, yeah. Py is equal to del L del Y dot. So it is my dot plus qbx, right? So what is your y dot? Y dot is py minus qbx divided by n. This is your y dot. Okay. So now let's make what is the Hamiltonian is. The Hamiltonian is px x dot plus py y dot plus pz z dot minus l. And what is pz? Pz is del l del z dot is equal to simply mz dot, right? So if you now calculate this these three terms, it will give you mx dot square plus my dot square plus mz dot square. Then again, x, if you have px is equal to this term, you will multiply it with x dot, you will get a minus qbyx dot. Similarly, your py is this term. If you multiply it with y dot, you will get a y dot here. So your qbxy dot. So this is the total this term, sorry, this term, and now you have minus l, that is m by 2 v square minus qbyx dot plus qbxy dot, right? So this is your total Hamiltonian. Now this two term will exactly cancel with each other. Okay, so you will simply left with m by 2x dot square plus y dot square plus z dot square. Right? This is your Hamiltonian. Now what is px dot? Px dot is m by 2 del L del x. Sorry, uh, dpx dt. Uh, Sorry, I probably made a mistake here. Sorry, px dot is probably I made a mistake here. Let's look at the problem some after time. Okay, so this is some capital Q and capital P. This is the transformation, and you have to calculate what is the generating functions f1, f2, f3, f4. So you have to know all the four transformation laws. Okay, so I already mentioned in a previous video that you have to remember this sign convention, that is plus minus plus plus minus minus plus minus. What is the significance of this? Let me tell you in a few moment. So the first one is f1 q, small q capital Q. So small p is equal to del f1 del q, and capital P is equal to the minus sign is here. So it is minus del f1 del q. Okay. So what is small p? Small p is simply 1 by q, that is del f1 del q. So f1 is equal to q by q. Okay. So you can also cross check with this. So this is q into p square. P square is 1 by q square is equal to minus del f1 del q. So again you are getting from this is q by small q by capital Q. So this option is correct. And as f4 is correct, I am showing you what will be f4, how you can calculate f4. So f4 is function of small p and capital P. So your small q is equal to del f4 del p, and small q is what? Small q is capital P. Sorry, this is not plus minus. This is minus plus. Okay, now plus minus plus plus minus 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 plus. Okay, so capital P by small p square, small p square del f4 del p, right? So you will get f4 is equal to capital P by small p. Okay, now check with other option. So capital Q is equal to plus del f4, this is minus. Okay, this is minus. So del f4 del capital P, and capital Q is equal to 1 by p, 1 by small p is equal to plus del f4 del capital P. So F4 is equal to capital P by small p. So both of them are these are giving the same result. So F4 is also correct, and if you calculate F2 and F3, F2 and F3 will not be correct. Okay. So option A and D are correct for this. This problem. So for this problem, you have to calculate what is Hamiltonian, Lagrangian, and V, this kind of thing. Okay. So Hamiltonian is simply root under p square c square plus m square c to the power 4 plus vx. Okay. So this option is correct. If you put this c square under the root, you will get this option. Okay. So what is now v? V is simply del h by del p, right? So you will get PC square divided by P square C square plus M square C to the power 4. Now if you take a C common and divide it in on both numerator and denominator, you will get PC divided by, here you have divided by C square, so you will only have P square here, and you will have M square C square here. Okay, this option is also correct. And now finally, what is L? So V is this term. So your L is equal to PV minus your H, right? So PV is P square C square divided by P square C square plus M square C to the power 4 minus root under P square C square plus M square C to the power 4 minus Vx, right? M square C to the power 4 minus Vx. Okay. So you will get minus ms square c to the power 4 divided by p square c square plus m square c to the power 4. Okay, now and minus v. So if you now substitute this p square c square plus m square in terms of v, you will get option D. Okay, so the significance of this, in Lagrangian, in the first term there is always a minus sign. You can calculate this. There is always a minus sign. You can immediately identify this which option, which Lagrangian is correct, because the minus sign is always there in this relativistic Hamiltonian Lagrangian formulation. Okay. Yeah. Now this problem. So you have to calculate the integral in this form, and your contour is unit circle. Okay. So for a is equal to 1, b is equal to 2, your z to the power 4 minus 1 is equal to z minus 0.5 into z minus 2, right? So your z minus 2 pole is outside the contour, is somewhere here, and z is equal to 0.5 is inside the contour somewhere here. So you have to calculate the residue only for this pole, 0.5 pole. Okay, so your residue will be 1 by 2 to the power 4 minus 1 divided by 1 by 2 minus 2. Okay, so you will get 15 by 16 divided by 3 by 2. Okay, so your answer will be 5 by 8. So this option is correct. And again, for a is equal to 2, b is equal to 1, the situation is equivalent. Just this 2 and minus 5 are swapping their positions, but the situation is exactly equivalent. So this option is also correct. Okay. Now for this problem, you have given this kind of potential formulation. So if you can remember, you can recall this, that if you have a conducting sphere at some, let's say, origin, and you have an electric field, external electric field is equal to E naught z hat, then your potential is exactly like this form. So your surface charge density is minus E out minus E in, that is del V del R. That is 3 epsilon naught E naught cos theta. This is your sigma. Okay, you have to take the derivative with respect to R and put then R is equal to capital R. Okay, so your sigma is like this. For r tends to infinity, your E is equal to E naught z hat, and z hat is not cos theta r hat. Z hat is equal to cos theta r hat minus sin theta theta hat, right? So this is your z. So this option is not correct. This option is also not correct because it is proportional to cos theta. And for electric field at any point, the curl free, yes, it is curl free. Electric field is curl free. And electric field at any point, the divergence for r greater than, it is also divergence free, because for r greater than r there is no charge present at all. Okay, so this is also divergence free. Okay, So these two options are not correct. Someone may do a little silly mistake that it is cos theta r hat because of the j hat, but j hat is not cos theta r hat. J hat is equal to cos theta r hat minus sin theta theta hat. Okay. Yeah. Now this problem, you have a medium infinite extent of permittivity epsilon r. So electric field is q by 4 pi epsilon naught e r square, right? And your d is q by 4 pi r square. So your P is equal to D minus epsilon naught E is equal to Q by 4 pi R square into 1 minus 1 by epsilon R. So this is your P, right? So yeah, your magnitude of polarization varies as 1 by R square is correct. If it is correct, it is not correct. And the magnitude of spring charge due to dielectric medium is less than the magnitude of point charge q is epsilon r greater than 1. Okay, so yeah, if epsilon r is greater than 1, this term, if you say this is 1, this is 1, say epsilon r is greater than 1, that is 2. So your polarization have q by 4 pi r square into 1 by 2, right? So what this, so this is epsilon r, and the electric field is also q by 4 pi epsilon naught r square into 1 by 2. So there is the effective charge is behaving like q by 2, right? So it is screened by some amount. Okay, so the C is correct. And for epsilon r is equal to 1, relative means more than, no, for epsilon r is equal to 1, it is exactly equal. Okay, so for epsilon r is equal to 1, your E is equal to simply q by 4 pi epsilon naught r square. So there is no screening, so q is equal to q. The effective charge which it is seeing is exactly is equal to q, not more than q. So it is wrong. Yeah. For this problem, you have a magnetization is m k hat in a cylinder. So what is your JB and what is your KB first? Let's calculate. So you have two kind of surfaces: this up top and bottom surfaces, and this curved surface. Okay. So for this curved surface, the normal direction is r hat. So KB for this curved surface is m k hat cross r hat, right? So your aims, this is aim phi hat. Okay. So the surface current density on the curved surface is non-zero. Yeah, it is correct. The surface current density on the flat surfaces, top and bottom, are non-zero. No, this is not true. Not true, because M, this top and bottom surface has normal k hat and minus k hat. So k hat cross k hat is also obviously zero. Okay, so it is not non-zero. So it is wrong. Bound current density is zero. So you have to check the cross product, right? So what is the cross product? R hat, R phi hat, Z hat, del del r, del del phi, del del z, and here 0 0 m, right? So if you take this cross product and there is some p factor of r, so it will be 0. Yeah, so bound current density is 0. Okay, and the magnetic field at any point outside the cylinder can be expressed at a gradient of scalar function, that is b is equal to saying that del cross A. Yeah, it's true, because for this kind of configuration where there is a surface current, surface bound current curling in the phi direction, so your current direction is like this. Okay, so it is like this. Okay, so it is simply like an infinite solenoid where your magnetic field is along this direction. Mu naught ni is the magnetic field for an infinite solenoid. So it is similarly like this configuration. So you can always use A dot dl is equal to B dot ds. Okay, or outside this region. B is only inside this region, so you can you can draw a circle of radius r greater than r, and your A into 2 pi r is simply mu naught in I into pi into capital R square, right? So if this has radius r, so this is your A. Yeah, so it's true that A is present there. You can write the magnetic field as curl of some scalar function, gradient of some scalar function. Okay, and for the next problem, cyclotrons are used to accelerate ions like deuterium sulfur particles, keeping the magnetic field same for both D and alpha extracted. So their kinetic energies is 10 and 20, and you have to calculate what is R alpha and RT, and their masses are also given. Okay, so you may have a little bit of confusion because of this MAVs, because you can assume that relativistic corrections will be needed. I mean, you should use relativistic prescription, but it is not true. See, these energies are of the order of 10 MeV and 20 MeV. and the rest mass of 2000 and 4000. So rest mass is much greater than their kinetic energy. Okay, so and if for some situation rest mass is much bigger, greater than the kinetic energies, then you would not need to do relativistic prescription. Okay, the simple class Newtonian picture is enough, good enough. Okay, because this rest mass energies are much greater than this. Okay, so R alpha is simply P alpha by Q into B, and RD is simply PD by Q into Q alpha QD into B. Okay, so what is P alpha? P alpha is root under 2 into M alpha. M alpha is 4000. And what is the energy? Energy is 20, right? And what is PD? P is 2 into 2000. MD is 2000. And what is KD? KD is equal to 10. So if you take the ratio, and what is Q alpha? Q alpha is 4, and what is QD? QD is 2. So if you take the ratio, we'll get the answer 1. Okay. The next problem, you have to calculate what is I beta basically. So you can use the loop equation. 10 minus 0.7 is equal to 100k into I beta plus 1k into beta plus 1 into I beta, because IE is equal to beta plus 1 into I beta. IB, sorry, I beta, not IB, not I beta, it is IB, the base current. So your IB is equal to 9.3 divided by 401 plus 1, that is 501. And you have to multiply it at 10 to the power 3, because you have to get the answer in microampere. Okay. So it will something 18 point something, I guess I forgot that, but this is the process. Okay. For the next problem, you have these three functions, 1 x square, and you have to you have to get a orthonormal basis of from this, and the normalization condition is given like this. So you have to calculate what is the value of a. Okay, so firstly you can think that you have to do the Gram-Schmidt orthonormalization process and all that, but that is not true, because they already give the form. Okay, so you don't need to do the Gram-Schmidt orthogonalization process. Okay, you just have to check the normalization condition. So for this, let's say if x squared is 3 by 2 into your x squared dx minus 1 to 1. Okay, so 3 by 2 into 2 by 3 is equal to 1. So normalization satisfied. If you calculate this term, it is 5 by 2 into x to the power 4 dx, right? So it is 5 by 2 minus 1 to 1. So it is 5 by 2 into 2 by 5 is equal to 1. So normalization satisfied. Now you have to check just the normalization for this. Okay. So it is 21 by 4 n into 5 x square minus 3 whole square into x square dx minus 1 to 1, it should be is equal to plus 1. So you don't need to remember anything from the Gram-Schmidt orthonormalization process. Okay, they already mentioned what is the functional form of this basis functions from the Gram-Schmidt orthonormalization process. Okay, so you just have to check the normalization, nothing else. Okay, so it is 25 x to the power 6 plus 9 x square minus 30 x to the power 4 dx, right? So 21 by 4 n into 25 into 2 by 7, that is 50 by 7, uh, plus 89 into 2 by 3, 18 by 3, minus 30 into 2, that is 60 divided by 5. Okay, so yeah, I guess this is correct. X to the power 5 by 5. Right. Okay, so 21 by 4 n into 50 by 7 minus 6, right? So it is 6, 3, 3 18 3 6, and 5 65 give you 12, so it is minus 6. So that is equal to 21 by 4 n into 8 by 7, that is equal to uh, 24 by 4n, that is equal to 6 by n. So 6 by n should be equal to 1, so your n should be equal to 6, right? Yeah, so this is 6. Now this problem, your H is kind of this form. So what is your and they are giving some relation. So you have to calculate what is the value of M. Okay. So Q dot is simply del H by del P, that is P by M. So what is your Q double dot? MQ double dot is simply P dot, and P dot is minus del H by del Q, right? So minus del H by del Q is what? Q squared del A by del Q plus 2Q into A, and this total term is equal to minus 5QA. So minus minus cancel. So your Q square, now A is only a function of Q, so don't need to take partial derivatives. You can take it as ordinary derivative. Okay, so is equal to 3QA, right? So your dA by dQ is equal to 3A by Q, right? So N is equal to 3 here. Okay, I already solved this one. So this one, okay. So five identical non-interacting particles with spin 3 by 2 are confined in a one-dimensional potential. So the lowest energy of the system is this. Okay, so spin 3 by 2 means the individual state can accommodate at least at most 2 into 3 by 2 plus 1, that is 4 particles. Okay, so and you have 5 particles. So ground state will have 4 particles, and the first excited will have 1 particle. So this state has energy 4 is equal to 1 units of pi square h cut square by 2 ml square, and this states are 1 into 4, that is again in units of this. So your total energy will be 8. Okay. Now this problem, see, your from the virtual ground concept, this V in will come to here. Okay, so your V out minus 5.1, Zener diode will only act in breakdown region. So if you have a Zener diode which is 5.1 volt is the operating voltage, breakdown voltage. So if this value, this two difference of voltages is greater than 5.1, then only it's operate. Otherwise it will act as an open switch. It will disconnect it. Okay. So your difference of these two should be such that it will always greater than 5.1. This thing you have to remember. Okay. So V out minus 5.1 minus V in divided by 1 kilo ohm is equal to V in divided by 1 kilo ohm. Right. So this is the current equation. So your V out is equal to 5.1 plus 2 V in. Right. Now V in is 1 sine omega t. So it is 5.1 plus 2 sine omega t. Right. The sine omega t have value minus 1 to 1, right? It can take value minus 1 to 1. Now, suppose you will assume now that what is the value this function I should take. I can take 0.5, I can take 0.3, whatever, because sine omega t varies from minus 1 to 1. So let's check with some, let's say 0.5. Okay. So 5.1 plus 2 into 0.5, that is 1, is equal to 6.1. You can say your V out is 6.1. Now look carefully. This difference is 6.1 minus V in, right? So difference between this and this is 6.1 minus V in. Okay. So when V in is V in is 1 sine omega t, so it can take value minus 1 to 1. So when sine omega t is 1, okay, so sine omega t is 1, sorry. So V in minus, sorry, let's make a mistake. I probably, okay, so V out is this value. Sorry, let's not go into this. Sorry, yeah. So so your V out is this, okay. So if you take a intermediate value, say V in is equal to 1 sine omega t, and if you take any intermediate value, let's say 0.5 or something, okay. So this will be 6.1 or something, okay. So if you take this kind of intermediate value, then this two difference sometimes can be less than 5.1, okay. So sometime less than, it can be sometime less than 5.1, and if it is less than 5.1, this will automatically be disconnected. Okay, so you have to ensure that your this value is such that it will always be connected, right? It will never be disconnected. So this difference between these two should be always greater than 5.1. So go with the maximum value, right? So if you take 5 plus 2 sine omega t, and if you take sine omega t is equal to 1, then your output will be 7.1. Okay, 7.1. And if you take this maximum value, then your difference, this difference and this difference is such that you have always this drop is always greater than 5.1. Okay, so v out minus this v in should be always greater than 5.1 plus this the drop in this case, that is 1 into I, the current flowing here. Okay, that means I am I want to tell that V out minus V in minus I into R, the current flowing through this resistance 1 into R, that is 1 kilo ohm, should be always greater than 5.1. Otherwise it will be disconnected, right? So to ensure this thing, you have to go with the maximum value of V naught. Okay, otherwise there may be such possibilities where this difference will be less than 5.1, and if this is the case, your circuit will be disconnected. Your circuit will be a open circuit, it will not be connected. So to ensure that your circuit always zener that always acts as a reverse or acts in reverse bias voltage, your this voltage drop should be always greater than 5.1. Okay, this all only can be ensured if we go with the maximum value of V0. The maximum value is V0 is 7.1. Okay, so the answer will be 7.1. Okay, so this is probably the last problem, and one problem I probably do some mistake, right? Yeah, this problem I guess. Okay, no, this problem I probably do a mistake in the uh, this is m by 2 x dot square plus y dot square plus z dot square. Now let write this x dot in some this configuration. X dot is px plus qby by m. So x dot is px plus qby by m whole square. Y dot is py minus qbx by m, that is py minus qbx by m whole square, and this is equal to p dot square by m square, right? So your Hamiltonian will be px plus qby whole square by 2m plus py minus qbx by 2m whole square by 2m plus pz square by 2m. So this will be your Hamiltonian, right? So yeah, so your option D will be correct. And now if you calculate what is px dot is simply minus del h by del x, and minus del h by del x is equal to what? You have to take derivative of this term, okay? And there is an extra minus sign sitting here, okay? So you will get qb by m into py minus qbx, and similarly for py dot, it is minus del h by del y. And now there is no negative sign sitting here, so you will get a negative sign in front of this. So minus qb by m px plus qby. Okay, so your option B and C are also correct. Okay, so these are the few 2 marks question which I solved, and probably 3 or 4 questions I am not able to solve at this moment, but I think this will be helpful. And okay, so thank you.